Hello everyone. In this class, our main study is the welding method of the vertical dip welding of the saddle tab tube sheet. Through this lesson, the main things we need to know are: master the operation essentials of this welding position, can formulate welding plans, can select welding parameters, can weld qualified workpieces according to welding safety, cleanliness, environment, and welding process requirements, can do appearance self-inspect of working piece according to standard. This is the construction drawing of the project. From the figure, we can see that this is a tube plate compression project. The compression is a riding type. The outer diameter of the tube is 76 millimeters. The wall thickness is 10 millimeters. The length is 88 millimeters, and the bevel angle is 50 degrees. The bottom plate is a square plate with a length of 100 millimeters and a width of 100 millimeters and a thickness of 12 millimeters. A through hole with a diameter of 56 millimeters is merged in the center of the bottom plate according to the inner diameter of the pipe. According to the thickness of the specimen and the angle of the groove, the size of welding leg is determined to be 8 millimeters, and a multi-layer multi-pass welding is used, which are 1 for the bottom layer and 3 for the cover layer. During the welding process, the saddle tab tube sheet vertical depression welding is in the flat welding position. When the bottom layer is welded, the molten pool is particularly easy to fall under the action of the arc brewing force and the gravity of the molten metal, resulting in the appearance of weld bed on the back of a weld. There are defects such as ultra-high welds, so during operation, it is necessary to strictly control the size of the molten hole and control the temperature of the molten pool to ensure that the root of bottom layer welding is fully penetrated without causing defects such as burn-through and welding flash. And because the tube sheet weld is at the root of the circumference of the tube, we need to constantly rotate the position of the arm and the wrist during welding to prevent the occurrence of the defects such as undercut and asymmetric welding fit. So there is still a certain degree of difficulty in operation. Before the welding operation, we must do the following welding preparations. 1. Safety inspection. Labor protection supplies must be properly worn and intact. Clean up the workplace and no inflammable and explosive materials are allowed. 2. Welding machine preparation. Check whether the welding machine cable, welding handle wire, and welding tongues are connected well, and carry out debugging. 3. Preparation of auxiliary tools. Prepare grinding wheel grinder, straight grinder, snake hammer, chisel, file, wire brush, steel ruler, and weld inspection ruler. 4. Preparation of the test piece. Check the size of the test piece according to the drawing and use tools to remove the oil stains, rust, oxide scale, etc. On the groove of the test piece and within 20 millimeters on both sides of the groove until the metallic luster is obtained. This is the test piece after grinding. 5. Preparation of welding materials. According to the material of the test piece, we choose E5015 electrode with better process performance, with the two specifications of 2.5 millimeters and 3.2 millimeters in diameter. It should be dried at 350 to 400 degrees Celsius before welding. Keep warm for 1 to 2 hours. Take it as you go. Then we start to assemble the test piece. First, put the tube and the bottom plate on the assembly platform and use a 3.2 millimeters electrode to support a gap of about 3 to 3.5 millimeters. Tack welding should be spot fixed from the inside of the groove. The spot in fixing points should not exceed 3 points, and the length of the tack weld at each point should not exceed 10 millimeters. The inner wall of the test piece tube and the hole of the plate after assembling the tack welding should be concentric, and there is no round edge. This is a schematic diagram of the point fixing position. Finally, measure the perpendicularity between the tube and the plate with a square ruler. The deviation after adjustment should be less than 2 degrees. This is an assembled test piece. Now we can start the welding of the bottom layer. For the welding of the bottom layer, we can use arc extinguishing welding or continuous arc welding. Here, we take arc extinguishing welding as an example to explain. Select the extrude with diameter of 2.5 millimeters and adjust the current from 70 to 85 A. Place the point fixed specimen vertically on the turning platform, and the angle of the electrode and the tube and the bottom plate respectively form an included angle of 45 degrees. The welding speed should not be too fast to prevent uneven distribution of the welding meat. The included angle with the welding direction should be based on the actual position. Keep turning your arms and wrist around 70 to 80 degrees. In the welding process, the arc should be short. The welding speed should not be too fast. The arc should stay at the root of the groove. 1/3 of the welding arc burns at the molten hole, and 2/3 is covered the molten pool, and the size of the molten hole should be maintained. Basically, consistent to avoid lack of fusion and incomplete penetration at the root of the weld. The welding speed should be uniform, and the frequency of arc extinguishing should be consistent, so that a neat and beautiful bottoming weld can be welded. After the primer is completed, the weld bed is cleaned up. This is test piece after primer is completed. Finally, the welding of the cover layer is carried out. The cover layer adopts multi-pass welding. The electrode with a diameter of 3.2 millimeters is selected, and the current is adjusted to 90 to 111 A. When welding the first pass of the cover layer, the center of the electrode should be aligned with the filling of the bottoming bed and the bottom plate. Line make the welding rod and the welding direction form an angle of 65 to 80 degrees, and the angle between the bottom plate and the bottom plate is 40 to 45 degrees. Adopt the straight line transport method. The transport speed should be uniform and stable, covering the bottom weld bed about 2/3. Ensure that the welding seam and the bottom plate are well fused and the edges are neat. To connect the second pass of the cover surface, the center of the electrode is aligned with the upper fusion line of the first pass of the cover surface, covering about 2/3 of the previous welding seam, and the angle between the electrode and the bottom plate is 45 to 50 degrees. The welding speed should be uniform and not too slow, so as to avoid undercuts or weld flashes, which will affect the formation of the weld bed. When welding the third pass of the cover layer, the method is basically the same as the second pass, and the current can be reduced by 5 to 10 amperes for welding to prevent undercut. Short arc welding must be used during welding to avoid defects such as pores and snag increase caused by excessive arc length. This is a schematic diagram of distribution of the finer bed and the angle of electrode. After the cover is completed, clean up the welding snag and spatter on the surface of the test plate. This is test piece after welding is completed. Key technology guide. The key technology points of the vertical dip welding of the widened tube sheet are: after the arc is ignited, The electrode is lightly leaned against the gap between the vertical tube and the bottom plate, and the melting of the electrode is used to drive the electrode to control the moving speed of the electrode. Tools and equipment must be sorted after the exercise. Turn off the power, clean up the site, make records. The surface of the test piece must be cleaned, but there should be no traces of processing, grinding or repairing, and then correct according to the score standard. Welds are not fused. Surface snag includes surface pores, cracks, weld thickness, weld neck symmetry, undercut, verticality, mechanical damage, or arc scratches, weld surface forming, and other items to carry out self-inspection and mutual inspection one-by-one check. Through the study of above content, I believe that the students have a basic understanding of the operation project. Welding high-quality welds must be diligent in practice. And in the practice, we must continue to explore, think, and summarize. That's all for today's content. Thank you.